Okay, so I had a lot of questions about slide 8 and slide 9 again. And unfortunately, since I didn't record the Zoom from last time, I wanted to take a couple minutes to do a quick video to kind of go through some of these examples. So this is number 3 on slide 8. One of the biggest things that people tend to get caught up on is the fact that there's lots of words in the question. I just need us to remember that these questions don't look any different than the ones that we were doing at the beginning of the year, right? They look the same. Ultimately, all you're looking for is question mark, what's the question asking me, and then the equals, which is the given. Okay, so let's read this question. It just says, how many grams of oxygen are necessary for the combustion of 425 grams of C7H16. The chemical equation is here. So the very first thing that we have to do is balance. So that's what we're going to do. So there's 7 carbons here. There's only 1 here. So I'm going to put a 7 here. 16 hydrogens here. Only 2 here. So I'm going to put an 8. And then 2 oxygens here. 7 times 2 is 14. Plus my 8 here. So 14 plus 8 is 22. Sorry, 22. So then I ask myself, what times 2 gives me 22? And the answer to that is 11. Okay, so a balanced chemical equation here is just 1, 11, 7, 8 are our coefficients. And then I'm just going to do the same thing that I've done in the past. I'm going to say question mark. What am I looking for? In this case, the question mark is grams. So I'm going to put grams. And it's specifically asking for oxygen, which oxygen is right here, O2. Equals, what's my given? I don't even have to read the question again. I just go where the number is because that's the given, right? And it says 425 grams of C7H16. So I'm going to say 425 grams of C7H16. And I'm going to set the conversion up, okay? Now, we've already talked about this, but we know that we now have a conversion from mole to mole of a substance because of the balanced chemical equation. So I know I can go from moles of O2 to moles of C7H16, but I don't have moles here, okay? So the first thing I have to do is convert out of grams into moles, and we do that by using the periodic table. So the first unit that I have to cancel is this grams of C7H16. So that has to go into the bottom. And I know for every 1 or for however many grams it is on the periodic table, I can then convert to moles of that. Okay, so then if you watch your units here, grams cancels, but you're not to the unit that you want. And anytime that happens, we know that we have to keep going with our conversions. So I need to add another conversion. So in this instance, I need to ask myself, okay, well, if I don't have the unit that I want, I have to cancel it again, okay? So if moles of C7H16 is here, it has to go into the bottom of the next conversion, okay? And then this is the new conversion that we just learned in this unit. Now we can go from mole of one substance to mole of another substance because I have a balanced chemical equation. So if the question ultimately wants grams of O2, I know now that I can go to moles of O2. So I'm going to put mole O2 in the top. And to find these numbers, I'm going to go to my chemical reaction, right? But I'm going to do that after I get all my units. So moles cancels. I'm still not to the unit that I want, so I have to keep going with another conversion. And again, whichever unit I want to cancel, it goes to the bottom. So moles of O2 will go in the bottom. And now I can grow to grams of O2 because we know that we can look on the periodic table to figure out how much 1 mole of oxygen weighs. So moles of O2 cancels. I'm left with the unit that I want. Now I can plug numbers in. This conversion is known as the molar mass conversion. This conversion is known as the mole ratio conversion. And then this is the molar mass conversion again. Okay, so molar mass, periodic table, mole ratio, chemical reaction. So I'm going to look here. Carbon weighs 12.01. So my calculator, I'm going to go 7 times 12.01 plus I had 16 hydrogens plus 16 times 1.01, because that's how much hydrogen weighs, which you can't see because there's a glare, 1.01 equals, so I'm getting the mass of this substance to be 100.23, and that's for every 1 mole. The only time that I don't use 1 with mole is when I look at the mole ratio. That's where I look at the balanced chemical equation. So there's an 11 in front of O2, so that gets 11. And then there's a 1 in front of C7H16, so that gets a 1. And then since I'm doing molar mass again, I can put 1 with the mole and then go back onto the periodic table and look. So there's oxygen weighs 16, there's 2 of them. So 16 times 2 is 32. And now I can plug this into my calculator. Times by the top, divide by the bottom. So I'm going to go 425 times 1 divided by 100.23 times 11 divided by 1 times 32 divided by 1. And I'm getting a pretty big number here. I'm going to need 1,493 grams of O2, but I started with 3 significant figures, so I'm going to change this 3 to a 0. So 1,490 grams of O2 is needed. Okay, hope that helps. Thanks.